All right. Hello, folks, and welcome to another edition of the Binding Status. I hope everyone is having a great week. Um, yeah, lots of stuff going on this week, I feel like, although maybe that's just in my life. But anyway, I feel really busy. But if you're busy, I hope this is kind of a time for you to come and just hang out with us this week. Me and Marcus have worked together a bunch in the past. So we're going to treat this kind of as just like a hacking session. A lot of what we're going to be using today and building today, we've been building over the past few hours, maybe past 48 hours, maybe. So definitely will be some rough edges and that sort of thing, but hopefully working through that will allow you to kind of see how some of the things happen behind the scenes for both Crossplane and Packet and Tinkerbell and some of the different things we're going to look at today. Before we really kick it off, just want to mention, as always, we will be active in the chat. So if you want to tell us where you're joining from, or ask any questions or help us when we inevitably get stuck on something, you are more than welcome to do so. Looks like Steven has also already dropped his name in the chat. He's joining from Florida. Thanks for joining, Steven. Jared, joining from France. Jared's a different place every episode now, so it's always cool to see that. And Muvafik joining from Istanbul. So we've got some pretty good diversity of location here. So that's pretty cool. But my guest today, as I mentioned earlier, is Marcus. Marcus and I have worked together on Crossplane, and Marcus is now doing a lot of stuff for Packet. And he's working on their integrations team and doing some new things around that. And so we're excited to see how Crossplane kind of integrates into some of the stuff that Packet does. We already had a Crossplane Packet provider, which I had worked on a little bit in the past, but I'd kind of fallen out of maintenance, and Marcus has really picked that back up. We've been working over it on the past few days. So excited to see that and some of the other projects Packet has in the pipeline. But Marcus, I'll stop talking and let you kind of introduce yourself. Tell us what you're up to. Tell us what you're interested in. Tell us how your day is going. Whatever you please.
Yeah, day's going well. Uh, I yeah, so what I've been interested in and what like brought me to Packet uh, is developer relations, is integrations, is working on all those sorts of tools. I did it at previous places. I learned a bit the contributing to Kubernetes tools like CSI drivers, CSM, Crossplane, and at Packet they have such needs, and so I found a home there. And I'm fairly new at Packet, so you can't quote me on anything that I say or say wrong, but uh, I'd like to just sort of walk through a tour of Packet. Is that all right? All right. Can I share
Yeah,
screen?
yeah. That definitely sounds good. Just for some context, so I mentioned before we're going to be doing some stuff with Crossplane and Packet, but we're also going to be trying to look into Tinkerbell a little bit, which is Packet's kind of bare metal provisioning open source project. And we both came into it knowing absolutely nothing. So I'm sure if any Packet folks are tuned in, that you probably know it better than we do. But we are going to try and take the approach of new users who might encounter it and stumble over some things and see if we can get it working. And hopefully we end up with a really clean workflow of using Crossplane to set up some of these machines on Packet. That then you can do some provisioning with Tinkerbell. So, but Marcus, as he said, is going to give us a little bit of background on what Packet is, because a lot of folks, including myself, I think a few months ago, were not really familiar with Packet and exactly their kind of like value proposition in the market.
Yeah, and I'm new to presenting that, so let's see how good I can present it. Wrong screen, right screen. Let's see, screen this one. There we go. All right, yeah. So Packet.com, an Equinix company, has recently been acquired by Equinix. I'll get to that in a second. But what Packet allows you to do, so a lot of folks who've been born into, as Gianluca, um, I don't know how to pronounce his last name, but he likes to say he was like born into the cloud. And a lot of people were born into the cloud and they never had to live through working with bare metal. but that's what Packet provides. They provide that bare metal experience, and it's accessible through the cloud. And so there's a lot of stories that you can tell about that, about having hardware that you own with the power that comes with that, and the low latency that comes with that, the control that comes with having your own machines on the cloud. And because of where Packet is located, that those resources are connected to all sorts of other managed resources that you might have, other managed infrastructure providers that you're working with. So you have this power and control right next to all of the other resources that you're using on the internet. And so they've got a bunch of partners who take advantage of this, and customers. And I just wanted to show that. There's this great story in here about Sprint being able to deliver projects like super quickly, because instead of having to bring up a whole data center and send your hardware there, they can just start spinning up bare metal in Packet. And Packet offers a lot of controls into what you can do there. You can have full control over the networking and connect those networks to other networks.
Yeah, it seems like since Packet kind of gives you you kind of are just given the primitives, right? And you can kind of piece them together how you want. It seems like not only are there advantages in terms of like latency and that sort of thing with bare metal and noisy neighbors and that sort of thing, but it might also just be an easier on-ramp for an organization that's typically running their own data centers. Like I definitely feel like when I use the console, which I'm sure we'll look at in a bit, that it's just super simple, right? It's like, this is a device and this is your network, and you can attach some storage if you want. And that it's just like, these are the primitives and you can build them up however you want. So if you're used to, doing that in your own data center, maybe for some of these companies, that's why it's been an advantageous product for them.
Yeah, and like as a developer too, if you're used to having your own home network and having all the control over that, or like as a hobbyist, you have that same sort of power here, full control over the network and the hardware on that network. Yeah, so compared to VMs, and VMs, you have this noisy neighbor experience where all of the VMs that are shared on the host that you're provisioned on, if somebody on there is taking up more CPU resources, then you're going to be affected by it, or more networking, more disk I/O, and here it's the box is effectively yours. Yeah, it's a few more partners. I thought this was really cool, and this is something that I didn't know about Packet when I joined, but you can provision Anthos on it, and that's something that I've just in the last few weeks I've had to take a closer look at it, and I've actually provisioned Anthos myself, and there's like a Terraform project, and just Terraform apply, and a few minutes later you've got that. There's a process you have to get, like a license key on the Google side, but it's all documented there. And then likewise with Openshift and the other partners here. The Openshift is interesting, and so with Anthos and Openshift, there's an interesting aspect of Packet is that they don't have a lot of managed services. They defer those managed services to their partners. So that makes it a slightly different cloud from some of the others that you're used to.
Yeah, I think definitely in terms of, how Crossplane looks at Packet, it's really nice because we also kind of deal in these primitives and allow you to build abstractions on top of them. So I specifically think of last show with Falco, we are showing some of the things you could do of varying levels of complexity with provisioning EKS clusters. And, you can kind of envision putting together some networking primitives and some Packet devices and that sort of thing in provisioning with, a single resource with just a couple of fields, like a Kubernetes cluster or something on Packet. So I think that's definitely attractive. Speaking from like a partner perspective, that definitely is something that that's attractive to us.
Yeah, so that having those primitives available, you want to get even more primitive networking, and the actual physical data center space is something that Equinix provides. And Equinix, you see that segue? Equinix So Equinix in January announced that they were acquiring Packet, and in March it's been completed. I think March is around the time that the team that I'm in now was starting to come together. So it's all kind of very new, and there's lots of exciting stuff that can happen when you take what the bare metal that Packet's providing and the networking primitives that Packet has been providing, and you mix that with the even more powerful networking primitives that Equinix has available, and the reach that Equinix has. So they're global. They're everywhere. They're super global, and they're connected to many cloud providers. In like, let's see, if we pick one of these regions, I don't know. Let's go with the big one.
Yeah, I feel like we were talking about kind of like the difference in interface for like a cloud platform versus someone like Equinix, because their customers are kind of these cloud platforms. And to be quite honest, I don't know too much about them. But I think I just made the assumption in my head that, lots of these cloud providers were just running their own data centers pretty much all the time. But it turns out, a company like Equinix is actually underlying quite a bit of that. And just like you get kind of like economies of scale from a cloud provider offering a lot of different services, you also get that, from a single like physical data center infrastructure provider supplying those services to the cloud providers to be able to then build on top of. So yeah, super interesting company that I feel like because it kind of like sits behind the cloud provider line that we don't hear about like from a consumer perspective too much.
There's an analogy that I wanted to try out.
Okay.
Yeah, so it's going to be corny maybe, but before we were calling it cloud, I think we were all calling it the information superhighway, right?
Mm-hmm.
And I was kind of thinking that, like, well, with Packet, it's like, instead of just getting, with managed services and with VMs, it's like you're getting like a taxi ride, or you're just having a delivery made, like the FedEx drivers out there with your package, and then it'll get dropped off where it needs to go. But with Packet, it's like you own a car or a truck, or in some cases, and more so with, if we extend that to Equinix, it's more like you own a commercial zone and you own a highway of your own. So I don't know. I'm going to play with that analogy and see if I can evolve that.
Yeah, no, it makes sense to me for sure. Definitely in terms of like having more kind of like ownership over the thing that's doing the transporting, and having a little more control over what's happening behind the scenes, which obviously, like, depending on your use case, that can be super advantageous, or maybe, a block, or maybe, if you're just writing Lambda functions or something like that, maybe Packet's not the way to go. But I've also seen that, especially some of these, like, serverless is a good example for this, because that's a pretty abstract form of managed service. If you look at OpenFaaS or Knative or something like that, I've seen them talk about Packet really positively, because they're able to do serverless type things now, having Kubernetes as kind of this operating system that can be deployed anywhere. And they get a lot of cost savings on doing that, on primitive bare metal. So still interesting to look at. It's interesting with now that we have like a lot of standardization from a systems perspective, that it makes it easier to piece together your own managed services, which before, you'd have to kind of like operate at the same level of complexity of a cloud provider.
Yeah, with those different managed services that are out there, you're sort of locked into what the managed service providers offer in terms of location. And when you look at these options, if you're willing to get those services, orchestrate them yourself, or find another provider who's taking advantage of Equinix or Packet, that it just gives you more options. There's restrictions on where your data can live in some territories, and what boundaries, what national boundaries, what country boundaries your data can travel.
Mm-hmm.
And so there's that need to get your data into those locations. And so if you're using a managed service provider, you're kind of limited to what they have. And if you're doing it yourself, you have a little more control over that. And then you just need to find your way into those regions. And so solutions like this make sense.
For sure. Yeah, I've always thought, for if you're like interacting with an Equinix kind of like type level infrastructure provider, like what's the lowest unit, the smallest unit that you can like consume from a consumer perspective? Like, could I get a server in a data center somewhere and pay Equinix for it? I'm guessing that they don't have packages for like hobbyists, and maybe like that's kind of where you'd interact with Packet, right? But it is interesting to kind of like see the scale of the companies that are customers of Equinix.
Yeah, and if you called up a data center and you said, yeah, I'd like to get my server shipped to you and have it racked for me,
Mm-hmm.
And I only want it there for an hour, that's the part where they probably tell you to go away.
Yeah.
So yeah, speaking of, this isn't a good segue at all. But so with all those capabilities, you need all the tools to make it useful. And so in the DevRel space, in the integration space, there's a lot of cloud tools available for users and for developers to write and work on and hack into whatever else they're making. So you've got every cloud provider has some raw underlying API, and then on top of that API, you need API clients, API wrappers, interfaces to different languages, and then from those you have your various tools, your CLIs and your Docker integrations and your Terraform integrations, and now you have your Kubernetes integrations. And then once you have that layer, then you have tools that take advantage of those tools that are like deeper integrations. And that area is a lot of what this team that I've joined is about, is providing the best experience around those tools, making them exist, keeping them well maintained, creating new integrations, and socializing the integrations that we have. And my director, Mark Coleman, wrote this blog post the other day, which it really sums up the things that our team is responsible for now, and kind of highlights the kind of things that we'll be responsible for going forward. But also these are the things that make it possible to work with Packet in a cloud native setting. So you'd wonder, is it possible to have a cluster API when you don't have a managed Kubernetes service? And the answer is yes. A cluster API is going to provision Packet infrastructure, and they've recently they've been working on HA capabilities for that. So if you have an existing cluster, in that cluster you can use cluster API to provision, say, three control plane nodes, and then from there a whole suite of Packet nodes in your cluster, worker nodes, and they can integrate with. So you don't even have a managed load balancer. How do you take care of that? So this CCM has to take advantage of Metal LB, and so it just goes on from there. It's interesting that things that you wouldn't think are possible on bare metal are possible. And so those integrations extend into partnerships with these other organizations, as we saw on that other slide, if you will, website, that you can do lots of things. And in this case, so you don't have a managed service to compete with your partners. Instead, you're enabling your partners to offer those managed services. I thought this was a really cool blog post.
Yeah.
Link
giving
below.
Yeah. Yeah, no, we'll definitely have these links and in the TBS repo as well. But I was reading through that, and specifically like something that we've had a show with some folks from Cluster API before. Yeah, a lot of people, talk about correlations kind of between Crossplane and Cluster API, where typically what we're saying is we will give you in a provider, we'll give you all the primitives that the cloud provider offers. So generally, we're able to also provision Kubernetes clusters, but we'll give you the managed flavor, right? So Cluster API is specifically like the AWS provider, for instance, doesn't go provision you an EKS cluster. It spins up some EC2 instances and uses kubeadmin to bootstrap those. So it's for self-managed Kubernetes, and that especially makes sense on Packet, where there is no managed Kubernetes offering. So you need to use something like that. It would be interesting, I think, if maybe in either Crossplane on top of Cluster API or the other way around. You could imagine having a primitive in the packet provider for Crossplane that's a Kubernetes cluster that actually just kind of like shells out to the Cluster API provider to bootstrap that for you, and then you can use building blocks just like you would for other managed resource types. Or on the other hand, I dropped a link to, we added the Cluster API provider for Packet to the documentation, crds.dev site this morning. And you can kind of look at some of the primitives there, which is like a packet cluster, packet machine template, et cetera. And I wonder for some of those, like the packet machine, if Crossplane was able to manage devices super well, then the Cluster API provider, for instance, could say, go create a Crossplane device. That being said, these projects kind of have different goals. Cluster API is typically for like bootstrapping a cluster and then, assuming management of it, rather than, having it running from this control plane long-term and consuming it. So it'd be interesting to see how those two things interact together.
Yeah, and we were chatting about the template stacks and the I know they're sort of outgoing, but that the Crossplane had the Kubernetes cluster claim types. Mm-hmm. And if you wanted to take advantage of Cluster API on Packet to somehow get to be resolved from a Crossplane claim, and all these things are going away. And I know composition is taking over, but I'm still interested in seeing if something like this becomes possible again.
Yeah. Well, we've definitely talked about defining some like common compositions, right? That maybe we even send with your installation of Crossplane. So, an infrastructure definition basically just creates a new claim type. So you could just have a Kubernetes cluster infrastructure definition, and that could be satisfied by EKS on AWS. It could be satisfied by the AWS Cluster API provider. It could be satisfied by the Packet Cluster API provider. It could be satisfied by a composition that you write in Crossplane of Packet devices. It's pretty extensible model. So I definitely think there's some cool stuff that could be done there.
Cool. Yeah, that catches us up to the Crossplane Packet provider. Like you mentioned earlier that this was started. Before I joined Packet. You had some contributions, and Jasmine here. I'm not going to try to pronounce his last name. But there's really kind of super primitive support in there right now. It's got support for devices, and over the last 48 hours, we've hacked on a few more pieces for the sake of the demos that we're going to try to throw together later today. And so the instructions here, if you want to play along, hopefully they get you through all the steps of getting this provisioned in Crossplane today with the latest version of this provider, which will actually probably update this to include the new resources that we've added today.
Mm-hmm. Yeah, I'm going to drop a link in the chat right now for anyone who wants to take a look at that repo. Do you want to go through kind of the, do you prefer to go through the Packet kind of like UI and console and that sort of thing first before we dive into?
I'll just take like a brief one, super brief one.
Cool.
So, no this is what the interface looks like. You've got different projects, different teams, and within that, you've got servers, you've got your network primitives that you can mess with. There's storage available. I didn't mention that earlier. I think my project ID is safe to share on the streaming internet. And these are machines that we'll be messing with. I don't want to jump too far ahead, but there's been a little bit of baking already. When you choose to create a new server, there's lots of regions available. Each of the regions has sort of a different selection of available hardware. It's not like VMs where you can just fake 10 million of them per region. These things take up actual real estate. So they have to, they are actual quantities here. There are physical quantities. You can't stretch them and make some VMs run thinner than others just to fit more people in. Yeah, I showed you the IP interfaces. Yeah, so if you wanted to add anything before I mentioned Tinkerbell, now's a good time.
No, go ahead. Let's go ahead and chat about Tinkerbell, and then we can go back and I'll kind of run through some of the stuff on the packet provider for Crossplane, and we can look at those new resource types that I have running, and then we can maybe jump into that device you have with Tinkerbell on it, and then try and get Crossplane running on it and see if we can break some stuff.
Cool. So if you're somebody like Packet, or you're just hobbying around with devices yourself, or you have space in a data center, then there are tools that you can take advantage of to provision your bare metal, take care of your networking, and so on and so forth. Tinkerbell is one such tool. It came from Packet. It was something that Packet developed for hosting Packet things, and it was open sourced a few months ago. And that's my background on that. There's a few more links that we'll include in here, including, I think you mentioned earlier that Alex Ellis was talking about it. So there's some links to some things that he's done. Mm-hmm. And I think that's about a good place to jump off.
Cool. Yeah, I'll show a little bit here about some of the changes that have been made to the packet provider recently. Let me pull up a few things before I switch this over to my screen. All right. Desktop 2. Okay, we should be good to go here. Okay, so as we mentioned before, there is a Crossplane provider for Packet, or a Packet provider for Crossplane might be the right way to say that, that you can go and try out. It was initially started early on because there's definitely been a lot of asks for like server support, I guess, in Crossplane. And I say server because, that could be typically people are asking for VMs like something like EC2 or Google Compute Engine or something like that. But in this case, they're actual bare metal servers, but they kind of give you a similar interface. And back when we did have hard to find claims, I wanted to add a server type claim, and you'll actually see some artifacts of that still in here. For instance, the server group here is what the device is in. Which we used to map those two claims. Now you can define whatever you want your claims to be, so it's not as relevant. But over the past 48 hours, as Marques was mentioning there, we have added support. Well, it's a PR open right now for the port assignment type. And then we also added the virtual network type, and also this network type support in a device. So what that allows you to do is, let me go over to the Tinkerbell GitHub. Let's see here. So what we wanted to do here was be able to provision the infrastructure we need to do this kind of like Tinkerbell demo here. And they had a setup with Terraform, which we were having some trouble with, but mostly what you need to be able to do is actually just create some devices and then get them wired up together. I'm going to move this over somewhere else. So let's look over at the GitHub repo. If you look in the Tink repo, which is the workflow engine, and look in deploy, you can see Terraform. It's a pretty simple Terraform script here. You'll see we are creating a virtual network or VLAN, and then some devices and a VLAN attachment, which is basically just saying for one of these ports on this device, we want it attached to the virtual network that we provisioned. We can do these same sorts of things in Crossplane, but we only had support for the device, so we need to support the virtual network and the assignment. So we added those types here. So you saw that the VLAN type was in there. It's a pretty small type. Basically, the only fields that you specify are the facility and description. So go create this network. And then for the port assignment, it's also fairly small. But because we have these cross-resource references in Crossplane, we can just reference that device and that virtual network, kind of like you saw was happening with the Terraform there. And so we added these two types. And if you want to take a look at, and we'll push this up after the show as well, in my examples, I have this TBS one where we're basically saying create a virtual network in this facility, create a device in this facility, and then do an assignment where we're just going to reference the device for the ID and reference the virtual network for the ID. And then the name is the name of the port on the device. And so basically what happens behind the scenes there is it goes and checks the ports on the device and sees if there's any assignment. And we actually found out, just kind of behind the scenes stuff here, I was checking for the ports on the machine, the attached virtual network ports, and you actually have to specify the href and compare it to the virtual network ID. For some reason, that's all you get back from the API. But if we look at this, and I'm just running this locally, so let's just take a look what's in the kind cluster. So we have Crossplane running here, and then you'll see I unpacked the provider packet, which means we basically installed the CRDs. I actually deleted the controller deployment, and I've been running it locally. So if we go down here, we should be able to see, I'll run it with the debug flag so we can see a little bit of what's going on. I probably still have those print statements in there, so it might be a little bit muddied up. But you'll see here, looking at the virtual network, the assignment and device, all of them are up to date. So that's really great. Basically, we provisioned those earlier, and I just paused the controller before the show started. So let's look at the devices. All right, so we have our virtual network here, and it is true and ready, and our device is true and ready. So those IDs are going to get assigned in the assignment. So if we actually take a look at the assignment here, let's describe it. We should see that referencing these resource types, these Kubernetes resource types in our assignment. And those are old, you can see, before we fix that href issue. Let's see. So we had our device ID ref. And so basically it went and pulled the device ID off that resource from the status. And same thing with the virtual network ID. For anyone who's interested in actually implementing some types in other providers or in the packet provider, essentially all you have to do is satisfy this interface, which if Muvafik's still on the call, he definitely had some influence on how this was designed, as well as Nick, who is on vacation right now. But for each type, if you want a field to be able to be referenced, you basically just need to create a reference extract value function that takes a managed resource and returns basically a field on that. And then in the resource, you just implement this resolve function, which basically says, I want this field to be populated from either this reference or selectors, and then assigned to this value. And you'll see we're using the function that we defined in the other group package to be able to do that. The selector is basically, we could have labeled, if we look back at our manifest here in the tbs.yaml, we could have labeled this device in this virtual network. And this is especially useful if you have like a group that you either don't care about which one it gets assigned to, or you want all of them assigned into a slice or something like that. You can just put the label and say, I want label TBS device to be here. So now that we have all of those things up and running, we kind of have the primitives here. But Marques has also done some work to get a device set up with Tinkerbell running on it. And so I'm going to pass it back over to you. And what we're thinking is we have this device set up in Tinkerbell running, which Tinkerbell has this concept of provisioners and workers. And we're going to try to, on the provisioner Tinkerbell device, which executes these workflows and kind of distributes them to the workers, we're going to try to run Crossplane to provision new workers and potentially a virtual network, I guess, as well. And then connect those up and then use Tinkerbell to do some provisioning on those worker nodes. So I'll pass it back over to you, Marques, if you want to kind of show what you've done so far over there.
Yep, I'm sharing my screen. We had a tmux open earlier, but it looks like that session was ended, so you might have to reconnect if you want to share tmux with me. So let's see, we provisioned, this device is already provisioned from Crossplane, from my laptop running Kind. I've provisioned this machine that we're going to run Tinkerbell on. I've stepped through the instructions already. I followed a slightly different path to getting Tinkerbell installed, but Tinkerbell is installed, and this is a window into the CLI that comes included in the instructions. Yeah, okay, that was weird because I already had the same prompt. But in here you can run Tink, and this is already wired to the Tink API that's installed on here for accessing the hardware and the templates and the workflows. And you can find out more about that in the concepts page in the docs. But what Tinkerbell is doing with hardware is allowing you to set up hardware profiles so that you can schedule workflows to those devices. And you have to create the hardware first, and then you have to tell Tinkerbell about it so that Tinkerbell can schedule work on them. And what we're hoping to do is have Crossplane provision those workers for us, that hardware for us. And there will be a point where we'll have to interpret what's in Crossplane to what Tinkerbell wants in a hardware YAML file. So I've got Kind installed. Let's see what happens. Cluster create cluster. Nope.
It's create cluster, I guess. Yeah, there we go.
And from here, I'm going to follow along with the instructions on the Crossplane provider packet site to get this provider loaded. I do have secrets prepared on here, so that's the only step that I'm going to skip.
Yeah, I feel like there's two kind of like different ways that, or actually there's many different ways you could kind of use Tinkerbell and Crossplane together. One of them is like they're on the same node in a cluster, if you will. So that's kind of like what we're doing here. They're on the same machine. And we're basically just using Crossplane to spin up new devices and then attach those to Tinkerbell. You also could, which we talked about a little bit before, it's been mentioned in the chat as well. If you had a kind of like Tinkerbell provider for Crossplane, then you could spin up these devices and then do some provisioning on them, creating like a CRD or annotating the device object itself. So that would also be something to get Tinkerbell like running in a Kubernetes cluster. And then another thing, I guess, is you could actually, in a Kubernetes cluster, if you had Tinkerbell running on a node, you could use it to add more nodes to the Kubernetes cluster. If you wanted those provisioned in a certain manner. So lots of interesting stuff. I really haven't gotten too deep, and I don't think Marques has either, into all the things you can do with Tinkerbell. It seems like it's pretty much a general purpose workflow engine. So you could kind of like execute any sort of logic on there. This is definitely catered for setting up bare metal machines. But I think the like generic thing on the Tinkerbell website is just a hello world workflow, which I'm not sure exactly what it does, but hopefully we'll see that here. So anyway, lots of different things you could do there. And we've talked about provisioners kind of in a Crossplane sense. So it'd be interesting to see how those interface.
Yeah, this is Flying by the seat of our pants here.
Yeah, so right now, Marcus is just getting cube control set up, and it looks like you already had kind set up, or you got kind set up, and you're connected to this cluster. So kind running on the node, and Tinkerbell also running in a, well, I guess they're both running in Docker. So this should be interesting.
Yeah, what does that look like? There's lots of fun. Yeah.
Let's see. Yeah, you see the.
It's like the
Yeah,
Tinkerbell's running a registry. Tinkerbell's got a server. We've got kind, and we should have. Do we not get visibility into the Crossplane? I would think that we would see.
Well,
that
it would be in the.
It's inside the node, but is the node not sharing the top level Docker?
Yeah,
Anyway.
I don't think so because it's running Docker in the container itself, right?
Yeah, I thought it would reflect it back up to the parent, but it's not. All right, so now I got the Crossplane CLI. I'm copy and pasting right out of the packet Crossplane provider packet instructions. I'm not changing anything here.
For installing the I guess you need my newest version,
right
of the provider. Do you
Yeah.
want me to push an image and you can use that?
Yep.
All right, cool. So on my side, while Marcus is doing this, I'm actually just going to build my local copy of Crossplane here. Let me move this over so I can still see what you're up to. Make sure you're not doing anything nefarious. All right. I guess I should probably remove my print statements before I do that, lest you have a.
Oh, I'm sure they're fine. I'm sure they make it better. What is your Docker org?
My username?
Yeah.
Hashdan. But I haven't pushed it yet, so let me do that real quick.
Crossplane provider packet with the tag TBS.
Yep, that sounds good.
I mean, I could just let this run. It'll keep trying until the image exists.
We might get into
the
back off though.
Right.
All right.
So like I said about if I can go home, I don't think I can go all the way back home. I'll Control C this and try again. But I'll create my secrets. I've already sourced my keys, and I named them with the same variable names that are in the README for the project.
Nice.
Let's see. I can create a packet. No, I can't create a packet provider yet until we have the package installed. So just wait for that image.
Right. All right. I'm pushing it now. Cool. So it's almost done. All right. Should be up. I'm going to go ahead and get a link and drop it in the chat for anyone who wants to take a look, who wants to see this glorious Docker container. Let's see, update a few seconds ago. I think I pushed some old stuff too. But yeah, this TBS tag should be good. Let's see, I'll drop it in there. That's a nasty looking link. Oh, okay, good. It gets abbreviated.
I'm also dropping the link to the instructions I've been following.
Nice.
All right. So is it pushed?
Yep.
Okay. And I've got your name right here.
That looks good.
Okay.
All right.
I have the hardest time transitioning from package to packet to package. Muscle memory is hard there. I'm like looking for my tab completion and they're not there. That's what I'm trying to do before I forgot that. kubectl get -n crossplane provider. Oh, so I don't have them all the way. Crossplane system
Is that where you install
provider.
it?
Yeah, that's what I had in the instructions. I know it's kind of gone from this being the de facto place for providers to find your own namespace, but I parked it there.
Let's see.
And find
You'll want to do package, right?
package. Yeah. Okay.
Looks good.
And I did not create the provider yet, did
I? No, just a secret.
All right. So I've got handy copy paste for that.
Nice. All right.
And from there, we can start provisioning packet devices and so on. So are you on the box?
I am not on the box. Hold on 1 second. I can also just share config with you if you want to do that.
Okay.
I don't remember exactly what we needed for the worker. Do you want to pull that up again? Or I guess you also have manifest for the device, so you could just create it directly.
Right.
Let's see. So for the already existing, the box that you're on right now, let's go ahead. We can start by creating and let me just drop this in Slack for you here. We can start by creating a virtual network. And then attaching, we need the provisioner that you're on right now to be attached to that, right?
We need the provisioner that, yes. And now I had some, yeah, I guess we don't need to actually create a resource for the provisioner itself. We'll just make the VLAN attachment to the provisioner.
Yeah, that'd be kind of like Inception if we had a device we were managing the device that we were in from the
because
device.
this device itself is already managed by
separate crossplane.
Yeah, by a separate crossplane. And we don't want them fighting over the properties.
Do you actually have, is that kind cluster on your local still running?
Yes. It's in a weird state though, because I uninstalled it while I was trying to upgrade it to the latest, and the package is gone, but the CRD is somehow persisted and the device is still there.
Nice.
Yeah, so I'm in a weird state.
All right. Did you see the virtual network there?
Yeah.
Cool. Yeah. So if we just can go ahead and show people that. Yeah. So you'll see it's pretty straightforward here.
Is it set paste? I haven't been in a while.
Nice. So yeah, we're just specifying the facility, which is the box that Marcus is on right now, is in SJC1, I think. So we're just going to create a new virtual network.
Do we want to create a new one, or do we want to inherit the one that we've created?
That's true. We could do that. Let me make sure that I kill my man. Oh, I already have. Cool. And I also want to make sure that I implemented the external name annotation correctly. I'm just looking at the observe method. So yeah, in Crossplane, for folks that are not familiar, you can assume an existing virtual network. Let's just try it. Why not? So you can name it whatever you want, but you need the external name, which is
loading up too, or if you get to it first.
Let's see. So I'll drop it in the video chat here. So this is the annotation that you need, crossplane.io/external-name. Okay, yeah, and you're already looking. So the name of the virtual network is not the VLAN. That 1156 is actually the VXLAN, which I'm not exactly sure how those are tracked on the packet side. What I can do, actually, right now, I'm just going to describe it.
I see. So you're saying I need to add an annotation with the external name is the way I'm going to get this imported properly.
Right. And you can actually keep the name, I think, whatever you want, though, the actual name of the resource.
Okay.
So let's see. the ID you need, because that's how Packet wants it in the request. So I'll drop this to you in Slack. All right, so that's what the external name should equal. And I have the controller stopped on my side, so should be a fine handoff.
All right, and I do or don't. I mean, status, I can just wipe it. This is
Yeah.
going to be fine.
Yep. You want to, let's just for fun say, we changed that description to Marques provisioning VLAN for Tinkerbell. I just want to see that it gets updated. Okay. I mean, we'll know pretty soon. Nice. If it worked or not. But it'd be kind of cool to see that changing the UI too. Okay.
Here we go. Do I need to? No, I think my resources have all been in the default. Well, there are no resources yet, so this is going straight into.
This is cluster scoped anyway, so.
Okay, and is the provider reference scoped properly? I mean, like namespace.
Provider is cluster scope, so you should be good.
Okay.
Actually, fun fact: you can get an issue with the namespace right now. In the next release of all the providers, this will be fixed. But if you supply a namespace for the provider, on some of them, you can run into issues. So don't do that. Let's see. True and synced.
I just want to share this because, that's awesome.
Yeah, right.
CTL get packet.
And I'm popping over here to see if it changed the description. Since it says ready and synced, it should have.
See if I reload.
It doesn't change for me, but it looks like you are managing it. You want to describe that virtual network?
Yeah.
I bet that I have an error in the logic as I implemented this extremely recently. Let's see. Is up to date.
This is really the only section you're interested in,
right? Yes. So description, live stolen VLAN. So that should not be matching the description we're getting back from Packet. But I don't know. So it obviously is saying that it says successfully requested update.
And our ID still matches. It didn't create a different one. Yeah, that's the same one.
Yeah, no, so that's good. So we definitely assumed control of it correctly. So for anyone watching, this is something you can do with any managed resources on Crossplane is use this external name annotation. So you can essentially import your existing infrastructure, which is really useful, right? If you're trying to move to a single control plane, you likely are not. I mean, maybe you're starting, startup and you don't have anything yet, but or maybe you're doing greenfield. But if you want to bring in existing stuff, one thing to watch out for is with the description here. If we didn't want it to be changed, well, the description is not required, so we could have just omitted it and it would have populated it from the provider. Actually, that's an idea. You want to try removing the description field and then applying again. And then let's see if it gives us the one from the other. That could be also. I'm just wondering where.
So we were going back and forth in the up-to-date logic on there's two return values that we had to introduce. One was if the device was up to date, and this is for devices. This isn't for the VLAN, so it's a little wrong. But whether or not a device was up to date and whether or not the networking of the device was up to date, because there's different API clients involved in updating the two pieces. And we just kept going back and forth about whether it should return true or false, meaning it is up to date or it needs to be updated. So it's the simple things that really kill you.
Yeah. Another great thing about this external name thing. So if we had created this directly, then Crossplane would have put the external name on there for us. So if you're using something, let's see. Oh yeah, see, it updated it. Interesting. I must have an issue with the update call. As Marcus said, we implemented this very quickly. But anyway, Yeah. So if Crossplane is setting these for you, so if we were creating a new one, we wouldn't set the external name there. We'd go provision the VLAN, and then Crossplane would set the external name for us. And then if you back that up with something like Valero, which basically just takes backups of resources in your Kubernetes cluster, then when you restore, like you could completely delete your cluster, create a new cluster, and then do a Valero restore, and you'll end up with the same infrastructure. It'll be managed actively by Crossplane. So it's a pretty cool setup, for sure.
You have I have a version of it, but it's going to take some tweaking. I don't know if maybe you have a clean version of this device resource that we want to make.
So I don't know. I created one, but I don't know if it fits the specifications that we need. In fact, I actually just pulled it from that one you sent.
Okay, so it's the same one, I guess.
Yeah. I guess we could look, although we don't know if the Terraform one is actually good. But we could look at how that's configured.
Yeah, this is what I've, right. That's essentially what I've done here. I've taken the fields from that provider, put them into here, modified a few things because who needs to go down the golden path? And is everything else in here right? Yes, looks good.
I'll get the assignment ready for you while you're doing that. What'd you call the device? Tink Worker 0?
Yeah. Tink Worker 0, yeah.
All right, cool.
Do you want me to include that in this resource, or we should probably just get this one running?
Yeah, just go ahead and get that one running because it'll take it a minute.
We're about to run on the end of the video, but I can stay for as long as we want to hang out.
I definitely think it's super valuable on when we have the shows that are like a little bit more formal, especially with like projects that folks aren't familiar with. But I think enjoy more like this kind of format, like this kind of what we did with Movafic a few weeks back as well, where he basically implemented a resource. What was it? PubSub on GCP in this, and I like kind of commentated. I like being a little more collaborative here, but like it's kind of fun I enjoy more of the hacking kind of side of it. And because you usually run into some interesting stuff, and then you have some takeaways that we can go fix stuff, or you learn something new. So, but yeah, all that to say that I'm happy to also stick around as long as you want. Also, unfortunately, we do have other responsibilities. So, yeah. Even though I know everyone who's watching this right now, probably doesn't have anything to do today but watch us. But unfortunately, we do have to go at some point. So. All right.
This is the provisioner that's in my local Crossplane. And so you can see that they're in the same region, which is nice. The important thing for connecting a VLAN between the two devices. And what this is doing on the Tinkerbell side is it's creating a layer 2 provisioning device that is both connected to the internet and is connected to a managed network that is not on the internet. And on that network, we're going to connect the worker. And this is sorry, I'll rewind. The provisioner is in a hybrid network state, where it has a layer 3 connection to the internet, and it has other NICs on it, which is something that's awesome in itself. These devices have multiple network interfaces, and you have that much flexibility over it. So the second interface is on this layer 2 network, which is connected to the worker that we're provisioning. And they're connected, they're on this, that's why the VLAN is there. That's like the managed network that they're communicating over. And on that network, we can, since it's layer 2, we can do things like DHCP. And that's what this worker needs. This worker needs to be able to DHCP to the provisioner, get bootp, get TFTP, all those sorts of protocols. I think bootp is not involved, but so that when this new worker boots up into iPXE, it can fetch from the provisioner all of the resources that it needs to fulfill the workflow that we would create. Which could just be boot an operating system, or it could be boot an operating system that runs a specific job. these workflow, the images that these workflows or that these workers run are hosted in the provisioner's image repository, and they are their images. I think you can also specify raw URLs to things like ISO images on the net, but they're Docker images essentially that get unpacked into the worker on boot up, which that's interesting to me too. Having experience in Crossplane development, that Docker images are used for packaging what used to be stacks and are now packages, except for the ones that are still stacks. and here they're being used to package up operating systems, so that the OCI format gets lots of points.
Is the are the Docker images, are they formatted in a specific way? Like how do you build those, or is it just you can put anything in there and it'll just run it?
I think it's everything. I think it's I don't think there's like a metadata file associated with it. I could be totally wrong about that. I think that it's whatever, essentially the tar of the Docker image is just extracted onto the box.
Gotcha. Yeah, one of the things I've been looking at recently is open containers. You know, like OCI, they are working on a they call it OCI artifacts. So it's basically, you know, a Docker container like thing that can be supported in a registry, but it could be kind of like arbitrary storage formats. So there's some really interesting stuff there, because like I know already Azure Container Registry, you can push a Helm chart to it. Like it's a Docker registry essentially, but you can push a Helm chart, which is basically just a specific layer format. And then you can pull that and run it and that sort of thing. So lots of interesting stuff happening there that I'm looking into in regards to packages and Crossplane as well.
Let's see how
I always like how you can see the provision percentage. That's like my favorite part. I remember when I added that initially, because like most providers aren't going to give you that back like in the API call. But down at the bottom in the status, you can see the actual like provisioning percentage of the resource, so you have a little more knowledge of what's happening. You could do a cool like CLI trick with that too, you know, to have some sort of animation in there.
My thought is I'm going to somehow repurpose this YAML for the hardware YAML. I don't know how compatible they are though. I think the other one might actually be JSON. So maybe I should have exported this as JSON. But do you want to throw out any kind of closing for anybody?
No, I don't think so.
Check out the next TBS in 2 weeks where it doesn't run over.
Do you? I mean, I can keep going if you want.
Yeah, no, I can too. I just don't know if you formatting wise.
We'll just keep going. If anyone wants to jump off, obviously, I mean, you can obviously do that whenever you want. But we'll keep working on this, and like maybe we'll have some good references in the future for people to look back at. We can point to timestamps and that sort of thing. So thank you for joining us. If you are strict on the hour watching, but yeah, I'm not gonna cut it up, so you can just keep going if you want.
Cool.
I'm doing a tweet right now, so maybe we'll get some other folks to jump on.
And I'm looking.
Looks like that worker's ready now.
Oh, cool.
On my side.
I'm loading up the hardware data. That's what our Tink API wants next. There are a lot of fields in here. I wonder if somebody's made a packet tool to convert this into a hardware YAML, or if this is just like the packet CLI output.
Like that's the API response.
Similar. Yeah. It doesn't look too similar. This is the minimal. Let's go with the minimal. Man, that no paste gets me every time. What do we know? This is the actual device ID, I assume. Well, that wouldn't make sense. Oh, this is, maybe it's just a UUID for the for this piece of hardware. I don't know if it actually maps to, it wouldn't make sense for it to map to anything on Packet. So maybe I'll just keep that the same. Or maybe I won't. So it's keeping track of things like the provisioning state. Maybe this is doing more than I thought. Or maybe provisioning has a different sense there. Provisioning is like this machine, this worker has been started and we're waiting for it to do its job.
I think this is maybe pulled off the status from Terraform. But that, I mean, I think that is the Packet ID, but I wouldn't imagine that Tinkerbell would care about that at all, right? Because it's not knowledgeable of Packet. It's probably just cares about the MAC address.
Yeah, so too. All right, this is probably gonna be easier if I have these in 2 separate windows. Just get the pieces that I'm interested in.
I've got a good action shot of you for this
Cool.
tweet.
Wow.
To all my many followers. Looks like Eric said this was super informative. Looked like he dropped off. Do you know, is he with Packet, or is he just was he just a viewer?
Yeah, he's in our team.
Oh, nice. Cool. Well, thanks for joining, Eric.
C2 medium x86, we're good there. Plain provision slug. Okay, well, I did say minimum. I think I don't need to fill it in. State provisioning. I don't know that would make sense to fill in here. It seems like this, it's like this is like state values coming from the Kubernetes side, and like maybe I don't need those.
Yeah. I'm pulling up the Tinkerbell documentation because I don't remember exactly what it does there.
And I don't know that we got what IP address this thing landed on. I guess it doesn't matter. I guess this is us assigning the IP address because we're in control of the DHCP server that it's going to use. I assume we have to fill in the MAC, which I don't think that field is being reported right now.
Wait, did you look at the hardware data section here?
I'm in the bottom version of the hardware data where it shows the minimal.
Oh, right. Yeah. I like the documentation here because at the top it says, if you have a hardware that has a single network worker device on it, its hardware data shall be structured like the following. I like the proclamation nature of it. This shall be done.
So we're looking for the MAC address.
Definitely something we should do, which would be like pretty easy, is to have a connection secret published from this that's already in the Tinkerbell desired format. You know what I mean? And then you could just easily spit this out. We could do some checking. That'd be pretty cool.
Let's see. I might have to break out the CLI to find this MAC address. Now we could try it. We could try to fail and just see what happens if I don't put in the MAC. But everything else in here seems okay, but I think I probably want to have the actual MAC address. And we're not using any of these other fields. Let me see if my CLI might not be configured for this project, so it might not be immediately available to me.
Yeah, I'm gonna go try it out on the API docs. You know how you can just like drop your API key in there and see if I can pull it off that way. Actually, the API docs, they don't have like a ton of information for Packet things. I mean, there's not that many things to talk about, I guess, but I love that you can just drop the API token in there and then actually just make the calls directly. That's pretty slick. Let's see.
I do have access to the device. I'm going to spit out the details in Yaml and see if I can find that.
Set token. All right. Retrieve a device.
I have 2 Macs. I think the one I'm interested in is the second one, but it's kind of a 50-50 here.
You're looking for the Mac for the Tink Worker 0, right?
Yeah.
Cool. I should have it here in a minute.
It's this, but the thing I'm not sure about is that there's 2 of them. There's 2 network cards, so it's either this one or it's the other one. This is the second one, so I'm guessing it's that. I don't suppose we have any like Tink experts sitting in chat telling us we're doing it wrong, right? No. Just don't do all Fs. Yeah. Oh, that'd be interesting. All right, so let's see. What do we do next?
So, by the way, thanks for joining, Duffy. We appreciate it. Definitely inspired by some of your TGIK episodes. The DNS ones have been great lately, so keep that up. Have you seen any of those episodes, Marcus?
No, I have lately not been watching as many podcasts or screen things as I normally do. Screencast.
Yeah,
webcast. Yeah.
You've had plenty going on.
Yeah, it's like you get into a new role and just dive into everything.
Right.
Yeah. So I want to do hardware. Push new hardware to Tink. That sounds reasonable. Do I get to tell it what file?
I think so. I remember that from the that's facility. -F for facility. That's misleading.
I need a facility used to build gRPC and HTTP URLs. I did give it one. I told it SJC1, but I don't know if it knows what that is, and I don't see like a Tink facility option. So
yeah, I'm a little bit confused about like how knowledgeable Tink is of Packet itself. I would think not at all, right?
Right.
But some of the things we're doing here give the illusion that it might be. So
yeah, and it's got its descendancy from Packet. So and it's a pretty new project. It's, whenever you see these new open source projects that come from behind gates, there's always hints of what was going on.
Yeah, honestly, like I'm not even hardware.yaml.
Oh, because I'm inside of a Docker container.
Oh, you could just Docker CP, right?
Can I do that?
I think so. Or do you have to do that before the
know the name of the? I was thinking I could just copy and paste it.
Oh, that also works just fine.
Let's see, how am I going to copy and paste it? I'm going to have to do one of these.
Yeah, I'm guessing this box does not have gosh, what is the program that I use for copying it into the clipboard on the command line? Is it Xcopy? Is that what it is?
Yeah. That was what I was thinking in my head. I'm like, nope, can't do that.
Yeah. I don't know what you've got Ubuntu on this box, right?
This laptop itself, yeah, it's got the Mr. Jobs logo up there.
No, I mean the
OS for
the Packet box.
The provisioner, yeah.
Yeah.
Ubuntu 2004. Okay, so now maybe it'll work. Tink hardware.json. Hardware data push successfully. Okay, folks, we ran Tinkerbell in Crossplane. I don't know
so
what
it worked, but let's see. Let's
try to make a job and see what happens. I don't know what the next step is.
Wait,
I didn't get this far in the instructions.
You can look at the. Isn't there a way to like list
hardware state?
CLI reference.
That other box is up right now. How does it? It has to tell it to shut down. To tell it to do new jobs. And I don't know how it does that. Does it like send a power off signal to the running box? Is the worker even ready to accept power off signals if that's the case?
What if you try doing Tink hardware all? I just want to see what that gives us. It says give all known hardware for facility. Oh, I guess you have to specify facility. Oh, so I guess maybe the facility is not a packet facility. But rather, well, it looks like that all is not available in this version of the command line, but it is in the reference, so maybe that needs to be updated.
Yeah, I did want to source that. I could source that and I could grab some of the environment variable. There's an envrc file here. I could try running tink not in this way.
Well, you could also, you want to just try tink hardware ID and then the ID of the machine. If you still have that handy, I can also drop it again to you. Just put it in Slack again just in case. Oh, there you go. You already have it.
You filled in the plant slug that I didn't have before. Or is that the field I did have? I think that's just provisioning says instance. Oh no, state is provisioning. Right, okay. So this is just exactly what I gave it before. I don't think anything looks different, right?
Yeah. So I guess does it not try anything before you actually try and run a workflow? Like, is it just like, you gave me this thing, well done?
This is the part where maybe we have to check out the instructions again. Hardware data, hold stuff, create one, lots of properties, the minimal.
And then I guess we want to do the hello world thing, right?
Yeah. Although, all right, yeah, let's do that. Now, I had copied some of those instructions. Terraform packet Tinkerbell, copied some of those here. Oh, I can get these two variables that we want. Now that we've sourced that, I think in this instruction, I forgot to mention that you can do that, or that you needed to do a source env. That. Okay, cool. And let's do this. And I think I'm going to need to create this hello world template too. Yeah, this confused me.
Yeah, this is just built into Docker, right?
Yeah, hello world is just right in library. I was like, where does this container come from? Where's the Docker file? How do I build it? Cool, everything just works. And then we need this template file. Oh man, let's see. Don't need it. That looks normal. Looks good. Looks good. All right. This device one, there's a note about that. It's the key for which corresponding value will appear. I'm not sure what that means, but I don't know if it has the map.
I think it takes it from, yeah, Tink workflow create, it looks like. So when we create, scroll down a bit, Tink workflow create template UID, and then it looks like you set device one to the MAC address or IP address, and then I think that just flows through.
All right, so we'll grab this line, which is the same as here. We're getting caught back up to the docs now.
Nice.
Tink is not found this because I think I gave myself the advanced instructions that said, well, you can run it in Docker, you can run it out of Docker. And so let's do that. Although I could probably switch to the other side. I could probably switch to the one that we already have running in the container. Did it already get? Wow, that's fast.
Oh, also this is late, but Duffy said xclip or pbcopy. That's right. Those are the commands we were thinking of. I think xclip is what I typically use. I guess I can just see. I'll run it and see.
Cool. All right, we created the template. And now, what do we do? Create a workflow, and we need the MAC address and the template UUID. All right, we got that. Let's save that so I don't lose it.
Do you need me to grab the MAC address for you again? Actually, I don't know
I can
which
get
one
it.
you went with.
Where was it again?
It
It's in the
in
worker hardware YAML.
networking?
Hardware YAML, which is hardware JSON on the other side. Confusing.
It's all the same. All the same to me.
All right, so we've got template ID. We've got a save Mac. See if there is a Mac and we'll override if something if there is. Okay. And now we're gonna do.
All right. What are the odds you think this works?
It's not gonna work.
That's so pessimistic.
How is it going to tell this other machine to like shut off? And all we've done is told it the MAC address. I feel like we're missing some steps.
Yeah, I think we are.
This is the device ID is the MAC or the IP address. That's interesting. $Mac. That's the workflow. All right, what's next? What could go wrong? Reboot the worker machine. That's what I was wondering about. Okay. Because if it can't turn the machine off, or how does it turn the machine off if like the worker that we've provisioned hasn't been configured in any way to accept like network power commands? So this must be it. Okay, reboot the worker machine. And I can packet CLI that, I think.
Yeah. There's a server actions on the UI as well I'm looking at. I wonder how we could do this with Crossplane, but it's such an imperative action. You know what I mean?
Yeah. Do we need one of these windows?
A great way to do it.
Throw it over there. Okay. Now that it's here, can turn into a tab. Man, I hate Macs. All right. So this is the machine that we're working on. And the thing that I wanted to do with it was not get it, but reboot it. Block it. I don't know if I want to reboot it or power it off. If I reboot it, is it going to automatically boot up into this, the Pixie config? Maybe that's some stuff that we left out. We needed to configure the Pixie URL on the worker, probably. But was that in the Terraform template or not?
Was it an output? Hold on, I'm looking back over at it.
The original Terraform. Or even in my Terraform, I think I didn't manipulate that block. iPixie script URL should be set to boot.netboot.xyz. I feel like that field is implemented in the Crossplane side, but
yes, I think so. I'm taking a look now.
I'm going to pull this. This is what I'll run when it comes time to reboot it.
Because I think we set the full spec, right? I don't know. Let's see. We have always Pixie. iPixie script URL. Is that what we want?
iPixie script URL. Yeah. That's one of the fields?
Yeah. I'm putting it in the YouTube chat. And also
so let's see if did that make it into the worker? Can we just set it? Right. Let's see, it's in the YouTube chat.
Yep. Also, I put it in Slack as well.
And
yeah, it's just camel case.
What do we have for viewers? Anybody sticking around?
We still have like 6 or 7 people on here.
The faithful, the courageous. All right, so we've got that, and then we need the URL, which is boot.netboot.xyz. This is insanity. How's that work? That's what's in the Terraform file. I don't think they're making it up. All right, an operating system I need to change to this. I don't know if these are properties that are settable or if these are only initial properties. Do you see if this is an updatable field operating system?
Yeah, let me see. it's camel case. It says it's immutable.
All right, so we should have had this one in there earlier. And we did have network type. Did we see network type make it through?
Yeah, I'm guessing you can't change.
Right.
Yeah, you can't do this anywhere on Packet, so we have to start.
It would take 20 some minutes for it. So this would be a good call-off point or cutoff point probably. But we can assume that it works at this point. We followed the instructions.
Yeah, well, I'll definitely produce some artifacts from this, right? And it doesn't seem like even looking at Alex's stuff where he was taking a shot at running this kind of thing. You know, he said it was challenging and stuff on Twitter. So it sounds like there's some room for improving the workflow here. So, I mean, selfishly from my perspective, I'd love to make Crossplane a easy way to do this.
Yeah, definitely. I'd like to see that.
Yeah. Well, cool. I mean, I feel pretty good about where we ended up here, honestly, especially because like half of the stuff we implemented in the last 48 hours, and it seems to be running like pretty smoothly. I mean, granted, the Packet API,
the description.
Yeah, the Packet, which actually I'm still not sure exactly why that didn't happen, but the Packet API is super straightforward, which makes it like it's kind of a breath of fresh air because, you know, I spend a lot of time doing like AWS or GCP devices, or not devices, but you know, managed services, and like recently I've been doing EKS cluster node pools or node groups, I think they call them, and you know, it's like 100 fields, and the configuration can be so many different things, and what's updatable and what's not is painful. So anyway, this was also a nice forcing function for getting the packet provider more up to date. I wonder if, you know, obviously you kind of like manage a lot of this stuff or help manage a lot of this stuff for Packet now. I wonder if y'all will get any inbound interest for using this. I don't really have like a good grasp of I mean, I guess I saw the like the customer page and stuff. I don't have a great grasp of like if your primary like client base would be super interested in this sort of thing. But I would imagine likely so. But
there are a lot of people using Kubernetes, even though there's not like a managed Kubernetes product. There's a lot of people using Kubernetes on the devices that they're managing. And as far as I can tell, all of our different provisioning tools are getting used in different ways. And the only limiting factor about the Crossplane one right now is that it's you know, it's kind of new and it only implements like 3 resources. But I think that if it implemented like a wider set of the available options, like, you know, configuring BGP, like how else are you going to configure BGP from inside of Kubernetes on, you know, in the real physical world? I think there's a lot of possibility there.
Yeah, I definitely agree with that. Well, maybe we can crank out a few more resources the next time. If you hear, definitely, I mean, like we chat pretty regularly, but if you hear folks asking for specific resource types, I'm obviously happy to jump in and contribute more as I have over the past few days. So yeah, it'd be cool to see this.
I'll have to drop some links to that stuff too. Did we already link to the packet provider?
I think I did at some point. Yeah. Well, thanks for the shout out, Duffy. If you explore this a little more, especially if you do it on TGIK or maybe you just want to come on, you can do it on here too if you want. If there's not space for a TGIK episode, we can run through some more of this. I'm sure we could both learn a lot from you in terms of what's going on behind the scenes here. So thanks for tuning in for sure. Well, cool. I guess we're about 30 minutes over now, so we can go ahead and wrap it up. But Marques, is there anything else you wanted to chat about today, or anything you're excited about specifically working on? I know you're doing some stuff with, is it Openshift? Is that right?
Yeah. So we have an Openshift UPI, which is a user provisioned infrastructure. And I'm working on getting the IPI, the Openshift installer provisioned infrastructure. And it'll be cool to have that. And then you'd be able to say, just go to the Openshift website, click a few buttons and have Openshift running on Packet. So
yeah,
that's fun. And that's what's like top of mind, other than, you know, like last minute scrambles to get things working in Crossplane.
Yeah. Fair enough. Is how does getting Openshift running on bare metal compare to like just plain Kubernetes?
Getting it running. So right now it's like a Terraform script is what the UPI is. So Terraform apply, and then you've got it. It's Terraform script. And maybe that's another step with the Crossplane installer for OpenShift.
Yeah.
And then run Crossplane inside of it.
Right. Right. Exactly.
Yeah, but the installer it's just like a command line tool. You run some commands, you tell it your API keys and your packet facility, and it will provision the nodes for you. It will set up the cluster API in there for you. The CCM and the CSI, all those things will be there, so that I think at that point there's a jumping off point, and you can start managing the cluster from Red Hat's UI, their OpenShift managed portal thing.
Yeah.
You have to plug in a license at some point in there.
Gotcha. Cool. Yeah, we've been doing some work with OpenShift, especially right now. I'm working with some folks over at Red Hat on getting getting the Quay operator, which I don't know if I'm saying that correctly. I never know. But it would Quay key or whatever. But getting that running, consuming managed services provisioned by Crossplane. So right now it uses in-cluster Redis and Postgres. And then I think you also, I don't know if it's restricted to S3, but I think it actually uses S3 buckets right now. So basically all these things, are supported by Crossplane. So you can have those managed services backing your registry, which you probably want as opposed to running Postgres in cluster if you have like a production deployment, but maybe not. I don't know how many folks are actually using the Kubernetes operator for Quay in production environments. I would guess few, but but that's complete speculation. So hopefully we can make that a little more robust.
Yeah, another thing that I'm interested in is like this whole Equinix acquisition means a lot of things are changing, getting more awesome at Packet. So
yeah,
those things to come also. Yeah.
Awesome. Well, sounds good, man. I'm glad that you are enjoying being over there, and it seems like you're already contributing a lot of stuff. So I'm not surprised, but I'm glad to see it. Yeah. So anyway, thanks for taking the time today. I definitely had a lot of fun preparing and actually doing this. So maybe we can get on again and hack some more pretty soon.
Awesome. Thanks for having me.